Hi, thank you very much for inviting me to speak to you. My name is Yanyan. I'm from Beijing Normal University. Today, I'm going to talk about intelligent learning scaffolding in multi-context, bridging research and applications. To prepare students to be successful, 21st century skills emphasize students' deep learning and competencies and skills. As a part of it, 4C skills of 21st century comprise 4 Cs, such as critical thinking, creativity, collaboration, and communication. And my team have been researching on collaborative learning for about 15 years. Collaborative learning has been at the center of educational and learning sciences since the 1980s. Numerous studies reported the benefits of collaborative learning, but collaborative learning is a challenging process that may not always lead to success. In the practices, there are some problems with students' performance, such as superficial information exchanging without meaningful knowledge construction, low student engagement, inconsistency of task understanding, tense atmosphere with a group, and etc. To overcome the weaknesses, a number of instructional interventions and strategies have been suggested to support for collaboration that is context-sensitive and interactive. Collaborative learning is a temporal unfolding process, and as such, can only be captured as a series of interactions emerging over time. In so doing, data is a very important driver of the learning process. We want our interventions to be designed with insight based on observations from a large number of students, so we know when to offer support that is going to be effective. In 2011 year, learning analytics emerged, which is a measurement, collection, analysis, and reporting of data about learners and their contexts for the purpose of understanding and optimizing learning and the environment in which it occurs. So we have a cycle of development, starting with data, which is multi-sources, such as a conversation, the logs, videos, or the learning artifacts of students. And then we use different technologies to analyze the learning process in terms of cognitive, behavioral, social, and emotional. In such analysis, we try to provide scaffolding via the script, group awareness tool, or virtual agent, and with the aim to improve students' learning performance, such as logic building, learning outcome, or other aspects. Therefore, we prepare or propose a multidimensional analysis model of online collaborative learning called KBS framework. It consists 3 aspects: its knowledge elaboration, behavior pattern, and social interaction. The knowledge elaboration reveals what is being discussed by the team members, and the behavior pattern focuses on how to discuss with others. The social interaction focuses on who they are talking with. And with such aims, we use different techniques to do such analysis, such as a content-oriented analysis. Here we can use a text mining to analyze the learner produced artifacts, and we can analyze the discussion transcripts. Also, we can use a process-oriented analysis based on the action logs and to detect the action patterns and also do some sequential analysis. Additionally, we can use some network analysis to analyze the social relationship between the team members and to measure their social relationship. Firstly, let's look at dashboards. You can see that we try to provide some dashboard to reflect the students' discussion. Here, you can see the logic coverage, equability, the focus. The focus just like the term crowd. We can see the frequency of the terms discussed by students. And this can give students a reflection or whether the talk is on the topic or off the topic. And a knowledge activation, here you can see that there are different corners. The green corner means the students talk about more on the topics, but the red corner means these topics are not mentioned by the students. And here, this dashboard can give the students a feedback or give the teachers to have a quick overview of the students' discussion progress. And the last dashboard, you can see that here is a temporal analysis of the students' discussion progress. And secondly, you can see the behavior pattern. When the students discuss on the forum, they can select the speech act when they post on the forum, and then the system can automatically analyze it and show some panel, such as you can see the description of their behavior category and the transition between the different behavior. That's a kind of feedback to give the team to say whether their talk is on the statement, or they just proper question, or they have some emotional communication. And the third is the social interaction. We just do some simple analysis of the relationship between them based on the interaction between them. And also we measure the centrality and cohesion within a team to see whether there is a leader in the team or there's someone who just stand by and not actively engaged in the discussion. In addition to the different dashboard feedback to the students, we try to analyze the students' performance in different granularity. We can analyze the students' individual performance or their discussion process, or they can see the groups or the class. In such way, the teacher can use such function to quickly compare the different students' behavior or the different groups' performance, or have a quick view of the whole class progress. And we have done some experiment study to see whether is it effective to support the students or the teachers. And we have been conducting the studies for a decade across the different contexts. We do in a real classroom, do the online teaching or learning, and also in a blended learning environment. And you can see we also conduct the experiment study in the elementary school, middle school, and college level. And the topic is from the engineering, science, and social sciences. So today I want to give you an example of our study, how to facilitate students' collaborative learning. And here is one of our experiment study. It is to investigate the effects of a group awareness tool on logic construction in cell. And this research was conducted in a semester-long course called Information Process Foundation. This course lasted for 16 weeks and was designed for blended learning, including weekly face-to-face lectures and 3 online collaborative discussion activities. And this research involved 93 freshmen, and they were randomly arranged into experiment study, experiment class, and control class. And on the right figure, you can see the experiment process. And here, we just select 3 very simple dashboards to present to the students when they discuss in the forum. And after the experiment study, we do some analysis such as the sequential pattern of their knowledge construction. And we do the interview of the students. And the semantic analysis reveals that students reported the cognitive and social group awareness were useful for the collaborative discussion, but it's a little bit surprising that the behavior group awareness was of little use for them. And finally, we get such findings and implications. The study reveals the positive effects of group awareness tool on logic construction in CSL in higher education, and more emphasis should be placed on incorporating multiple group awareness types by tool developers when they build a platform. And third is that given the mechanism of group awareness, it might inspire new ideas in designers and educational practitioners to develop and utilize the GA tools in diverse learning contexts. Last but not least, teachers and curriculum designers may need to design and implement instructional programs to get students pay more attention to self and group members' participation. After do such kind of experiment study, we find some expected and unexpected findings. So we want to explore why the students have such experience or behaviors. So we try to do the social regulation analysis. And in the conceptual framework of social regulation, we design such a framework to analyze it. It comprises 3 aspects. The first is the task conditions. It can be divided into 2 types. The first is external condition, that is learning environment, task requirement. And the internal includes the prior knowledge, motivation. Also, we can see that the regulation comprises 3: self-regulating, co-regulating, and social share regulation. And the learning performance concludes a group level and individual level. For the group level, you can see we emphasize the learning atmosphere of the groups. And also, I want to share with you another experiment study. This is the wiki-supported collaborating in the context of learning English as a foreign language. And this is the real scenario experiment study. And this campus course lasted for 16 weeks. And the students studied the English reading, and they just communicate and discuss based on the wiki platform. And based on our theoretical foundation, we analyze the regular type, process, and focus. And we compare the high-performing groups and low-performing groups. What's the difference between them? And now, I want you to watch a short video.
Wow, is this the room?
I think so. Wow, nice room. What's it?
Welcome.
Oh.
We'll be starting shortly.
Wow, she looks cool.
Yeah.
What's her name?
Nice to see you. I'm Agent Rachel. Please take a moment to introduce yourselves.
Hello, I am Joe.
Howdy, Joe.
Hi, I am Eric.
Howdy, Eric.
Today we'll practice pair programming as you collaborate on the diamond kata exercise. We'll use test-driven development. For the first test case, why don't you start as the driver, Eric?
Okay.
Joe, why don't you start as the navigator?
Sure.
When you've reached your seats, you can start on the first test case. Time to switch the driver and navigator roles.
Okay, so how can we do
Okay,
that?
what do we
Why
need to
don't
do?
you be the driver, Joe?
Sure.
Eric, you will be the navigator.
Okay.
Okay, let's start.
Yeah. Okay, you can.
Oh, yes, sure.
In the future,
Oh,
please
sorry.
be more careful
Sorry.
about social distancing.
So we can start your move.
Yeah.
Hi, just now you just watch a video. This is camera in the CMU, and my PhD student collaborating with him to do a virtual agent. And
Wow,
here,
is this the room?
you can see we set up the different the cameras, the microphone array, and other sensors. And this is try to capture the person's eye gaze, the gestures, and their positions. And you can see that if the social distance is just is too close, and the agent will remain them friendly, and it's just experiment study. And this is called smart office. And also, we set up a virtual human agent in Beijing, Beijing Normal University. And also, we embedded other scaffolding, such as scripting and group awareness. And with such combination of different scaffolding, we try to intervene the collaboration study. We try to support students when they encounter some problem during a discussion, and especially on the social regulated learning. And we are conducting work, and maybe in later we have more progress. And so far, we have collaborating with different universities such as CMU, Sparks University, and Hong Kong U. And also, we try to bridge our academic study with the real scenario application, especially in the industries parties. So, we have a National Engineering Laboratory for Cyber Learning and Intelligent Technology. And this lab is collaborated with several corporations and universities such as the Dragon, Athletic, China Mobile, and Tsinghua universities. And I am the Dean of the Logic Modeling Analysis Lab. And with collaborating with the Tsinghua universities RD Center, our focus on the logic graph. And here we have built up a K-12 educational logic graph, and it covers Chinese, Math, English, and several types disciplines. And we have more than 22 billion instances. And we can see that it's a very big large graph. And here just give some examples such as geography, math, and English. And we have a very huge large graph on different subjects. And also, right now, we are preparing for a new attribute standard for the K-12 educational KG. And this is just we are just doing the document preparation. And we wish, if you have interest, you can join us to do such work. And based on the logic graph constructed we have set up a platform try to give the support the logic services. And here you can see that there is an open interface, and we can support the open data interface and the documents, and the user can register on it. And after verification, you can use the logic graph for some three-part programming application. Also, in the platform, we provide some logic services such as intelligent QA and logic link extraction and the intelligent text recognition. And this is one application collaborated with Channel Mobile. Channel Mobile has a platform which can provide video conference lessons. And here you can see that by automatically analyze the videos, we can extract the logic points just to show here. And when the students want to log in to study this lesson, it can check the logic points. And here, this is matched with the logic graph. And the sixth application is called AI plus logic analysis. Here, we try to link the content or logic points taught by teachers to logic graph, and it automatically analyzes the text and try to give the cloud term, third cloud to show the teacher presentation by matching with the logic points in the logic graphs. And the third application is domain logic graph. It's about the Chinese Asian poetry. Here, the platform is the semantic retrieval and the visualization platform for tongue density. Based on the literature experts, the poetry theme, emotion style, poet's experience, and social interaction are instructed and visualized by NLP technology. And here you can see that this is a social relationship between the points. And here is the description of the poems collected to the places in which the poem touch on the place. And after we done the logic graph of tongue density, it includes, you can see that 43,000 tongue poems and more than 2,000 points and 20 types of links. And we already extended to the poetry covered from pre-Qin to the Ming and the Qin dynasty, and the total skill reached more than you can see that 204,000 poems. And the links have been further expanded to 5 dynasties, seasons, solar terms, and festivals. And also, we do some gamified learning with logic graph. Here as WeChat mini programs we have developed, and you can try it if you have interested. Finally, I want to share with you the factors to consider when using artificial intelligence in education. We thought that the education is very complex because it is kind of interdisciplinary area. And secondly, it's diversity in educational contexts. We can say there is individual learning, collaborative learning, or MOOCs, and we can learn in the classroom and blended learning and totally online learning. And also, you see that when we do some scaffolding, we want to provide students with accurate support, and trial and error, we can't afford that. And finally, ethics and security issues must be considered in the education application. So that's all that I want to share with you. And thank you very much.